and welcome everyone to today's Synergist product demo webinar, the new Gilian Go-Cal Pro Airflow Calibrator. I'm Kay Bechtold, Managing Editor of the Synergist, the magazine of AIHA. I'd like to thank everyone for joining us today, and especially Sensidyne for sponsoring this webinar. Today's product demo is scheduled for 30 minutes, and we have a lot to cover, so I'm going to dive right in and quickly introduce today's speaker, Aaron Apostolico. Aaron is Corporate Industrial Hygienist and Product Applications and Research Manager for Sensidyne. He is responsible for the company's corporate IH program and managing the product applications across the business. Aaron currently holds professional designations as a Certified Industrial Hygienist, Certified Safety Professional, and Certified Indoor Environmental Consultant. And now I'll turn the presentation over to Aaron.
Thank you, Kay. I'm going to start by sharing my screen. And it's really an honor and pleasure to talk to you about our newest product, the Gilian Go-Cal Pro. It is the latest technology airflow calibrator. Today we're going to go over a little bit of an overview of the product and talk about some key benefits and features, which include accuracy, portability, ease of use, sample integrity, as well as the technology advancements in calibration in general. I'd like to start off this presentation with sharing a short video of our product demo. And now I will switch back over. Wait 1 second. Back to our presentation. So as you saw in the video, the Go-Cal Pro is really designed to simplify flow rate calibration of your industrial hygiene air sampling pumps. The system uses a technology which is made up of venturi and critical orifice, which creates a very stable flow path that goes through very accurate pressure differential sensors to measure that precise airflow. Now we have 3 different flow models. We have a low flow model, which ranges from 5 cc's all the way up to 600 cc's, predominantly used for your sorbent tube and gases and vapor states. You have your standard flow range, which is going to go from 500 cc's all the way up to 5 liters per minute. And then you have your high flow, which ranges from 3,000 cc's all the way up to 30,000 cc's or 30 liters per minute. Of course, the high flow range is going to be used more for some of those high flow samplers, which are now becoming more in demand, as well as those area and environmental sampling pumps. So when we talk about the features and benefits of a product, it's important to note that end users look for certain, I would say, certain benefits, and we're really responsive to their end user needs. And that usually includes accuracy, portability of an instrument. It has to be easy to use. It has to be able to provide sampling integrity. And then they really want a product that uses advanced technological equipment that is the latest and greatest on the market. So let's talk a little bit further about the accuracy of the instrument. The Go-Cal Pro is designed to be 1% accurate across the flow range of each of the instrument models. It's used to reliably set an accurate flow rate on your air sampling pump, and it can provide a percent deviation to show the flow stability. And this is really important factor because you want to be both accurate as well as precise when you're setting that flow rate. It's engineered with mass flow differential pressure technology, and then it is calibrated against a NIST traceable source within our certified ISO 17025 laboratory. When we talk about portability, it was important to design a product that was small, durable, and lightweight, and also has no moving parts, so it's easy to travel with. The Go-Cal Pro weighs approximately 0.75 pounds, so it's 3/4 of a pound, again, making it easy to store and transport. Its handheld ergonomic design makes it easy to hold and perform data entry. We'll talk a little bit more about the actual user interface in an upcoming slide. It also should be noted that it's easily charged with a standard USB-C cable, which is provided with the starter kits. Setup. End users want a product that they can take right out of the box. You let it stabilize to your local climate and environment. You would turn it on. You could connect your tubing to your media and to your sample pump and start it right up. At this point, you'll see live readings because it stabilizes very fast and provides that instantaneous flow rate. You can also set a user selected time that you would like a sample to be averaged over. Furthermore, you can customize your settings for local languages as well as preferred units of measurement, such as temperature in Celsius or Fahrenheit, your barometric pressure readings in inches of water or HPA or KPA. And you can navigate through these settings on our large color touchscreen display. When we talk about sample integrity, it's important that the calibrator can also create digital traceability, which ties your whole sampling chain together. So what does that mean? You're tying together your air sampling media and its identification with the pump that it's being sampled on, with the user that it's being sampled on, and then the calibrator and the results of the calibrator that it is being flow verified with. Now, this flow verification event can be stored and data entry can be performed using that color touchscreen display. The flow meter report actually creates an event that can be downloaded and printed out. And this will give you information, again, about the flow meter, when it was last calibrated, and then tied together, as I mentioned before, your sampling pump, your user information, as well as your sample ID. Next, we want to talk a little bit about the advancements in calibration technology over the years. It has evolved initially from traditional bubble burettes. Those of us who actually, studied back in school and how to use bubble burettes to calculate flow rate know how challenging it was to set up and actually time bubbles between 2 points along this burette. In the 1980s or so, we developed wet cells with optical sensors. It now added a mechanical plunger that was able to create the soap bubble, and optical sensors which can actually time the movement as it graduated up the cylinder. It also provided results in a digital format and could average multiple samples. Over the years, we went away from the soap bubbles, although it's still widely used today, to new dry cell calibrators, which became a little bit more portable and had less interface in the sense that it had a dry graphite puck that would move up and down a cylinder, also using optical sensors to look at the travel of flow and time it and provide a digital output. Other technologies that were on the market included hot wire technology, which you've seen in multiple products. Hot wire technology, again, was fast and could be in a more small, compact, portable unit. But again, one of the trade-offs was you would lose some of the accuracy and stability of the reading. Most of those units were greater, 2% or greater accurate. And then we come to our newest products and newer technologies, which include the Venturi laminar flow units. Now, while Venturi laminar flows have been around for a long time, the sensor technology has improved, allowing us to achieve that 1% accurate across the flow range. These mass flow sensors and pressure transducers, as well as your ambient temperature and pressure sensors, give added metadata to record and actually use for comparison of your event. Now, lastly, we'll talk about the event logging with the user interface. Now, this is something that is really unique to the Go-Cal Pro series, and it allows that user to manually enter in that information about the sampler being used, whether that's your pump ID, whether it's your sample ID on your media, or the user that is actually wearing the sample ID, or it could be an area if you were taking an area sample. And all of that would get logged and stored within that event of your flow verification. So while many advancements have been made in calibration technology, volumetric burettes are still used today, but you can see how the improvements over the years has really increased convenience while maintaining accuracy, precision, and stability. And using the advanced circuitry and sensors really allows for end user ease of use and I would say that stability needed to provide the most accurate flow rate. Newer technology calibrators also can be configured to meet the user's end needs. Now, these calibrators are more convenient versus the traditional soap bubble calibrators due to eliminating the need to manually generate the soap bubbles and the use of the soap bubble solution. I mentioned earlier that some of the other advanced features include the ability to select sample periods. So if you wanted to average your sample over 5 seconds, 10 seconds, 15 seconds to really make sure that you have stability and not looking at just a short period of time, you can use that sample set to now record your starting flow rate for your air sampling device. Additionally, users have the flexibility to set their engineering units, date, time, and temperature, and choose from various languages in the device library. Internal sensors within the unit allow you to convert to a reference temperature and a reference pressure to get an STP volumetric flow rate. Now that STP flow rate corrects the volumetric flow rate to an STP corrected flow rate. And this can be used to facilitate data comparisons across different environmental conditions, eliminating the need for external calculators. So the calculation uses the combined gas law to equate your ambient temperature and pressure to a reference temperature and pressure held everything else equal. Now, users can set that corrected temperature and pressure according to the values of the various standards, whether that's an STP that's recognized locally or an NTP value. Furthermore, Onboard computing can data log the calibration events and perform some statistical analysis on the deviations between the readings. So this is that percent deviation that I mentioned earlier. And what that is really doing is taking the average and then looking how far above and below the average the data points were collected. And obviously, the larger that number, the more pulsation you're seeing from the pump. Specifically, if you're trying to calibrate devices using a size selective sampler, a cyclone, or a PPI, you would really want to make sure you have as minimal pulsation as possible. And this is a good indication of whether you're seeing pulsation from your air sampling pump. Now, the users can define the statistical parameters for that percent deviation such that if it's above that parameter, that value will change from green to red, letting you know that that pulsation is present in your air sampling device. So our color touchscreen keyboard also has the capability of allowing the user interface with a typical QWERTY keyboard to enter in those defined fields, such as the pump model, pump serial number, user information, and sample ID. Some additional information that you can find within the settings could include the serial number of the calibrator, what firmware version it has, when it was last calibrated, as well as its proposed service due date. The service contact information is also provided for easy access to our factory ISO 17025 service and calibration laboratory. I further wanted to discuss the calibration report. So the calibrators store that sample information along with the user input data and puts it into a calibration log. Now this feature simplifies the addition of calibration data to your air sampling report and enables easy retrieval of historical records for statistical analysis. And as someone who has performed years and years of field sampling, it's important to be mindful of transcribing notes. Often pump identification, calibration data, and sample name can get mixed up, especially when collecting multiple samples simultaneously. That concludes my presentation. At this time, I would like to open it up to see if there's any questions, and I'd be happy to answer them at this time.
Okay, great. Thanks, Aaron. It looks like we have about 10 or 11 minutes left for questions. Just a reminder, if you'd like to ask a question, please type it into the chat window on the right side of your screen and send it to everyone. Aaron, the first question we have is, why is digital traceability important?
Sure. Digital traceability is something that I have worked with, as a consultant, but also for a lot of the forensic investigations. What can happen is, we should treat all samples like it has to be defended in a court of law. And ultimately, there's times when it does have to be defended in a court of law. And one of the questions that would get asked by the opposing counsel would be, did you calibrate your pump? And of course, they would want to have some sort of record of that, as well as when was your calibrator last calibrated? Again, they would want to see some record of that. And all of that is part of that digital traceability. So to be able to show that you have a flow verification report showing that there wasn't a large deviation between your starting flow and your ending flow, and that you have that in a digital format, makes it much easier to defend, especially if you had to defend it in a court of law, or if there was an actual occupational injury or illness that had resulted from the exposures that were being monitored.
Okay, great. Thank you. The next question I have is, what is percent deviation and how does that add value?
Sure. So I talked a little bit about what percent deviation does. It looks at your average flow rate, and then it monitors those points above and below it, and it shows that percent deviation. I mentioned real early in the introduction that it's important to be both precise as well as accurate. And precision says that, my grouping, all right, is very tight. Well, you can have a very tight grouping, but if it's not on point and it's not accurate as well, you're really not at the flow rate that you think you're at. All right. And especially when you're using those size selective samplers, if you had a flow rate that was pulsating quite a bit, so your grouping is not very tight, even though it was accurate on average, what happens is you're actually oversampling certain particle sizes because of the aerodynamics of those particles with the cyclone or the PPI that are getting pulled in.
Okay, got it. Thanks, Aaron. The next question I have is how much sample time should you average?
Well, this can really be up to the end users. We have some presets that are built into the device. They start at 5 seconds, and I think they go 10, 15, and 30. And then you have an option to put in your own value, which I believe you can put all the way up to 5,000 seconds. There really isn't a need to average that long for air sampling pumps, of course, but you want to have a sufficient enough sample where you're able to capture if there actually is pulsation in it. Usually, I would say somewhere around 10 seconds is what I would typically set for it. If you're just trying to validate it, maybe a flow rate at the end of the work shift, 5 seconds might be enough just to get an average to see and compare that to your starting flow rate. So it really depends on what your options are, but I wouldn't go less than 5 seconds. I would say 10 seconds is usually a good target, but the longer you have that sample for, if you have time to run a longer average, the more you may capture any pulsation that pump may display.
Okay, thanks, Aaron. The next question I have comes from Chris, who asks, are you going to advertise this device as a primary calibrator?
So yes, but it's important to understand what a primary calibrator is. A primary calibrator is a working standard that is NIST traceable. Um, it also, in this case, is a 1% accurate device. So it's meeting the definition as far as meteorologically, what a primary standard being NIST traceable to a primary function is. We've seen different definitions in the past using that term primary. But as long as it is a 1% accurate device that is NIST traceable and it follows that working standard, it meets that definition.
Got it. Thanks, Aaron. Keeping an eye on my chat window here, I don't see any other questions right this second, but I figure we can give people just another minute or two in case they have some questions. In the meantime, Aaron, are there any other questions that commonly pop up when you talk about this new product or anything else you'd like to discuss?
The only other thing that, comes to mind is, obviously people traveling with it, things that, you might want to consider is, you know, runtime and, how long will it last for in the field. I can tell you that, you could probably get over, 300 to 400 calibrations on a single charge, which for most people, can last several weeks in the field. Typically, people are calibrating their air sampling pumps, for an hour at the beginning of the day and maybe 30 minutes or so doing a post-cal flow verification. Um, the you know runtime of it also can be affected by the screen brightness. So you have the ability to set the screen brightness. If you're inside, you really don't need it on full bright. However, because it's so portable, if you were to use it outside and you need a little bit brighter, you can actually adjust that in the in the settings to make the screen brighter as well.
Okay, great. Thanks, Aaron. The next question I have is, do you know, are you able to speak to how does this instrument compare to the new SKC Checkmate flow calibrator?
Sure. So the SKC Checkmate uses somewhat of a similar, technology, but some of the key differences are additional sensors for ambient temperature and pressure. Also having that user interface and looking at that percent deviation. So we really feel that, you want to have, not just an accurate instrument, but finding out and understanding what your environmental conditions are, what are the ambient temperature and pressure that you're calibrating in, and understanding how that can actually impact what your flow rates are. And then further, being able to actually store a record and actually have that digital traceability. So these are definitely some differences. I would say the SKC product, while it's a very simple and basic product, it basically turns on and just provides a flow rate. I'm not sure if it actually averages and stores any of that. I don't believe it has that capability. So one of the things that I find, if you're just looking at something that has a live display, sometimes that number keeps moving and shifting. And it's hard to actually record exactly which number you should land on. Whereas with our sampler, with our airflow calibrator, you can actually take an average sample over a time period, and then you actually have a, average multi-point number that you can use as your starting flow rate and compare that to another average at the conclusion of your sampling event.
Great, thanks, Aaron. I think we've got time for one more question. I just saw another come in asking, is it intrinsically safe?
So it is not intrinsically safe. That's really, I would say that I'm aware of. I don't know if there's any calibrators on the market that are intrinsically safe, generally because you calibrate in a safe environment. You're not really going out into the field and performing, calibrations in hazardous areas. We do know that people want to check on their pumps kind of throughout the day. We generally ask that, you do that in an area that is safe. So at this time, no, it is not an intrinsically safe instrument, but we do try to listen to our customers and what their needs are. And, if that is a product demand, most certainly we can look into maybe coming up with a model sometime in the future.
Okay, great. Thanks, Aaron. Unfortunately, that's all the time we have for today. I see just a handful of other questions. Just wanted everyone to know that we'll be sharing all questions from today's event with Sensidyne. So if we didn't get to your question, please know that we will pass it along. I wanted to thank you, Aaron, for your presentation, Sensidyne for sponsoring today's product demo webinar, and all of our participants. Our Synergist webinar series will pick back up again in the coming months. Please check aiha.webvent.tv for updates. Thanks everyone again, and have a great day.
Thank you.
Thank you, everyone. This actually concludes today's demo. Thank you for attending. The recording will be available at aiha.webvent.tv. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts.